FastMCP 3 employs a server-level transform pattern to bridge protocol gaps between clients and prompt-based interactions. The system uses a decorator-driven approach to define parameterized prompt templates, which are then exposed as tools through a transform pipeline. We're about to examine how a FastMCP server initializes with labeled identification, defines two distinct prompt templates using the @MCP, prompt decorator, and applies the PromptsAsTools transform to generate tool-based access to these prompts. This setup will demonstrate how the transform creates the list prompts and get prompt tools that enable protocol-agnostic client access to server prompts. From FastMCP, import FastMCP. From FastMCP server transforms, import PromptsAsTools. MCP equals FastMCP my server. @MCP, prompt. Def analyze code. SDR language, SDR equals Python SDR. Analyze code for potential issues. Return F, analyze this language code, \encode. @MCP, prompt. Def explain concept, SDR. Explain a programming concept. Return F explain, concept. Hash add the transform, creates list prompts and get prompt tools. MCP, add transform PromptsAsTools. This code demonstrates FastMCP's pattern for creating parameterized prompt templates and exposing them as tools for clients that don't support the prompt protocol directly. The @MCP, prompt decorator defines reusable templates like analyze code and explain concept, which accept parameters and return formatted strings. These prompts become first-class components in the MCP server, accessible through the standard protocol. The key pattern here is the PromptsAsTools transform, which bridges the gap between prompt-based and tool-based clients. When added to the server, it automatically generates two tools: list prompts for discovering available prompts with their arguments, and get prompt for rendering specific prompts with provided parameters. This transform approach follows the middleware pattern, where components flow through the transform chain before reaching clients. The generated tools route through the server's middleware at runtime, ensuring consistent application of auth, visibility, and rate-limiting policies. This design enables broader client compatibility while maintaining the server's security and operational constraints. The trade-off is slight overhead from the transform layer, but it provides a clean abstraction that separates prompt definition from client access patterns. For production use, you'd apply this transform to a dedicated FastMCP server instance if you need to expose only a subset of prompts, as the transform operates at the server level, not the provider level. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, making it available for creating MCP server instances. From FastMCP server transforms, import PromptsAsTools. Imports the PromptsAsTools transform class from the FastMCP server transforms module, enabling the conversion of prompts into tool-like interfaces that can be exposed through the MCP protocol. MCP equals FastMCP my server. Creates a FastMCP server instance named MCP with the identifier my server. The string parameter serves as a server label for protocol handshakes, allowing clients to identify this specific server instance during MCP communications. No functional configuration or operational mode is set by this name. It's purely for identification purposes in the protocol. @MCP, prompt. Def analyze code, SDR language, SDR equals Python SDR. Analyze code for potential issues. Defines a function, analyze code, decorated with @MCP, prompt, which creates a reusable prompt template for MCP clients. The function takes a required code string parameter and an optional language parameter defaulting to Python, and returns a string. The doc string indicates this prompt is designed to analyze code for potential issues.
Return F, analyze this language code, \encode.
Returns a formatted string that combines a language identifier and code content into a single analysis prompt. The F string interpolates the language and code variables into a template that begins with analyze this, followed by the language name, then code, and the actual code content on a new line. This creates a standardized prompt structure for code analysis requests.
@MCP, prompt. Def explain concept, SDR. Explain a programming concept.
Defines a parameterized prompt template named explain concept that takes a string parameter concept and returns a string explanation. The @MCP prompt decorator registers this as a reusable prompt in the MCP system, making it available for clients to request explanations of programming concepts through the protocol.
Return F explain concept.
Returns a formatted string that starts with explain, followed by the value of the concept variable. This creates a simple explanation message by interpolating the concept into the string template.
#add the transform, creates list prompts and get prompt tools. MCP, add transform PromptsAsTools.
Adds a server-level transform to the FastMCP instance that exposes all registered prompts as callable tools. The transform receives the server instance as its only parameter, enabling the generated tools to route through the server's middleware chain during execution. This creates two new tools: list prompts for discovering available prompts, and get prompt for rendering specific prompts with arguments. FastMCP 3's server-level transform pattern bridges protocol gaps by converting parameterized prompt templates into tool-based interfaces. The @MCP prompt decorator defines reusable templates like analyze code and explain concept, which become first-class server components. When the PromptsAsTools transform is applied, it automatically generates two tools: list prompts for discovery and get prompt for rendering. These tools route through the server's middleware chain, ensuring consistent application of security and operational policies. The key insight is that this transform approach maintains a clean separation between prompt definition and client access patterns, enabling broader compatibility while preserving server constraints. The slight overhead from the transform layer is justified by the abstraction it provides, making it ideal for production scenarios where protocol flexibility is required.
The decorator crafts tools that call it home. Who answers when the builder becomes the doorbell?